smokeless chimney, candle testing is easy. Or is it? We burned one candle wick, just like we burned one incense stick. Let's see how it goes. This is a close-up of the data. Okay, let's talk about some of this below zero stuff. When there's not much smoke in the sensing area, when the light strikes small particles, it will actually reflect them or make them brighter ever so slightly, like 1% or so. And this is why, or at least my hypothesis as to why, we get negative opacity readings. This first data anomaly is where my arm blocks the beam. We can ignore that, it's not smoke. The next thing I want to point out is the difference of the color shift. Well, it's actually very similar to the opacity. They're derived in different ways. We almost don't need the opacity to determine whether or not there's smoke. Simply a shifting color may be enough. I was intrigued by this section of the curve, and I think what's going on here is I'm using a cap to limit airflow, and this may be the candle flame oscillating between too rich and too lean. It's clear to this observer that the pre-flame set readings and the post-test readings are at zero. This indicates a working system that was not altered by the test. These are some photos from our test setup. I used the lid that I use in the incense test to keep the smoke regulated. One thing to note is that if you don't have air going into the chamber, your candle, well, one, it's going to smoke, but it's not going to burn like a candle normally does. This is good testing because the system is designed for wood stoves and possibly pellet stoves. If we can measure a candle the way we do you think we can measure the emissions of a pellet stove? A wood stove is relatively simple. They put out smoke, but there's high temperature gases. The system is designed for these high temperature gases.
Winter chills us to the bone, but smokeless chimneys bright and warm. Clean air for everyone in every form. Less smoke for skies so blue. The future's bright, it's up to you.